Hello everybody, and welcome to exercise 1 on page 16 of the workbook. This is another exercise in trying to find the form of the partial fractions decomposition of a function. So remember what they're asking us to do in each of these problems. They're just asking us to take each function and to break it into its pieces, okay, according to that decomposition that we talked about previously. Okay, so if we start with part A here, we've got a function that looks like 10 over x squared minus x minus 6. We want to break that down into its partial fractions decomposition. We would start by asking, can we do any factoring here? Notice that in the bottom, x squared minus x minus 6 factors as x minus 3 times x plus 2. We can break it down. Okay, and so what that tells us then is, you look at the denominator, we've got two linear factors, x minus 3 and x plus 2. Neither of those factors are repeated, and so all that we should need are two terms with constants above them. So we'll need an a over x minus 3, that takes care of the linear term x minus 3, plus a b over x plus 2, that takes care of the linear term x plus 2. And since they asked us to not solve for the constants, we're done. Okay, that's what our decomposition looks like. Okay, what about part B here? Well, same idea. So we're going to start with our fraction and ask, can we break it down at all? So 3 minus 2x in the top. And x squared minus 6x minus 9, that actually factors as x minus 3 times x minus 3. And what about the x squared plus 1? Can we factor that? That's irreducible, okay, because of the plus 1 that we've got there. We can't factor that. Okay, so we get x minus 3 times x minus 3 times x squared plus 1 in the denominator. Notice that we can rewrite that one more time, noticing that the x minus 3 occurs twice, like that. It's important to rewrite it that way because it points out the fact that what we're really looking at here is a repeated linear. X minus 3 is a linear factor that's repeated twice. Okay, the x squared plus 1, as we just said a minute ago, that's an irreducible quadratic. Okay, and with those two observations, we're ready to write down our partial fractions decomposition. Okay, so starting with the repeated linear term, we need two terms to account for that. So a over x minus 3 plus b over x minus 3 squared. Two terms because of the fact that that's repeated twice. Okay, and then what about the x squared plus 1? What do we need for that? Well, because it's quadratic and not linear, we need a cx plus d on the top instead of just a c. That's the difference between a linear and a quadratic factor. Okay, and so this is what our partial fractions decomposition would look like. Okay, and what about c then here? Well, same thing. So we want to think about whether we can factor the denominator. And in this case, if you look at the first term in the denominator, x to the 5th minus x cubed, we can factor an x cubed out of that. Okay, rewrite it like this. So x squared plus 4 squared, that's already factored, so we'll leave it alone. And then notice that the x squared minus 1, that can also be factored as x minus 1 times x plus 1. So x cubed, x minus 1 times x plus 1 times x squared plus 4 squared. Okay, so there's a lot going on in this fraction. Let's see if we can attack these terms one at a time here. So starting with the x cubed in the bottom, okay, notice that that's the linear factor, x, repeated 3 times. It's being raised to the 3rd power. So what we need are 3 terms, okay, to account for that. So a over x, b over x squared, and c over x cubed. A, b, and c because the term is linear. Okay, we don't need any x's in the numerator. Okay, that takes care of the x cubed. And then we come to x minus 1. That's a linear factor as well, and it's not repeated, so we just need one term for it, d over x minus 1. Okay, then we come to x plus 1, same deal, that's linear, and it's not repeated. Okay, and then finally we come to the most interesting of all of them, the x squared plus 4 squared. Notice that that is a repeated irreducible quadratic. X squared plus 4 is a quadratic term and it's being repeated twice. So we need two terms because of that repetition, starting with x squared plus 4. And because it's quadratic, we actually need an fx and a g in the top, and then one more term because of that repetition, hx plus I. Okay, wow, that was a lot of work. We have a lot of terms there, but that's our partial fractions decomposition. Okay, and just a comment before we end this example. Okay, if we had been asked to integrate any of these functions, then we would have actually needed to figure out what these constants are, okay, and then do the integral after we find the constants. In future videos, we'll do an example where we kind of do all of that at once again.